you go! Well done! Get going! Yeah, push!
What it needs, Marky, is a motor.
An engine. Vroom, vroom. Oh, do the steering. Good boy.
Okay, so here's the motor, or the converted alternator. Came out of a Ford Fiesta. The other day I converted that. Basically ripped it apart and just connected out the coils and made a three-phase brushless, well, a three-phase motor out of it. This is the field windings. Yeah, so plan is something like this. Well, the gist of it anyway. But in order to do that, this needs to come off and be modified. So that's the next job. The idea is put that somewhere here. So I need to make a bracket up and take the wheel off. In fact, let's just mount it a little bit better than this. Hang on. Right. I'm obviously trying to do this on the cheap, so the alternator was donated to me and it came off a Ford Fiesta, so it was quite a small one, and I'm glad it is now, because with that and then the seat, it's going to be tight. There's a recess in the seat, so it would sort of fit there, but then the cog, the sprocket won't reach out far enough to meet. So I think what I'm going to do, just the little lad's a bit short anyway, is probably mount another rail, steel rail, so I can bring the seat up and forward, somewhere like that, which will give me enough room to just bring the motor over. And then I'm using spare bits. This is a sprocket. I don't know, I haven't gone into the ratios of this, so I don't know what it's going to be like. I don't want a fast go-kart. He's barely able to steer the thing as it is. I'm pushing him and pulling him. So I'm hoping to be able to gear this right down until he gets familiar with it, and then dial it up over time. I've got a 11 tooth cog that I'm going to weld onto here, and I've got the chain that basically all this stuff is stuff I had knocking around. So I'm really hoping that I won't actually need to buy too much. I've got a motor controller coming from good old eBay, and yeah, I'm going to make a battery pack up. Well, I might show that in another video. But the idea for this came about because my son hasn't got the strength in his legs to push himself along with this yet. And what I thought would be quite cool is if I could make some kind of pedal assist like you do with e-bikes. And so as soon as you put a sensor basically on here, and as soon as the sensor notes that you're rotating the pedals, it basically gives you motor assistance, and I thought that would be really cool. The problem is that this thing doesn't have basically when you're pedaling, it doesn't allow for a sort of overrun. So if you stop pedaling and there's momentum and the motor is actually propelling you forward, the pedals are going around regardless, and so it's a recipe for disaster. So plan B is to actually not have a chain on here at all, and just have the pedals that can go round with the pedal assist. This may actually change again because I'm still concerned that he can put his feet or get his feet caught. I was going to put some checker plates, some aluminium checker plate here, so he can't put his feet on the floor, but I don't think I can do both and have it safe. So I might end up doing away with the pedals altogether and just having a little sort of a accelerator pedal, electronic accelerator pedal down here somewhere. But I'm not quite there yet. I think the first stage is to get this mounted together. Yeah. Good morning. Today's another day in the build of my little lad's go-kart. I ripped the back axle, as you can clearly see, and there was, as I was doing it, I thought it might be quite a good idea to explain an idea that I had. Basically, at the moment, this go-kart, when you're pedalling, obviously the chain goes on here, as you're pedalling, it's actually only driving one wheel, and that can be seen here with the basically this bar that just slots in between the spokes of the wheel, making it basically fixed to the actual axle, whereas the other side is free. So it makes it great for work, for sort of pedaling on normal roads and or driveways and things like that. However, if you're going to make this a little bit better and power it, there are going to be times where I'd quite like it to be able to go across a garden and lawn and things, and I'm wondering whether that will be enough traction. So in the middle here we have, on the original go-kart, when you click this lever, which is the one in the centre of the car, it knocks the drive into neutral. Now this is going to be redundant. I've decided to not use this when I electrify it because I don't want him to be in a situation where the cart's going quite quickly and the pedals are moving really fast and he ends up hurting his feet. So I'm going to just remove all of this, but this is quite a useful little device, and all it does is it just pulls this cog apart from the actual drive, the actual axle, and allows it to sort of freely rotate, which essentially means the pedal stays still whilst the axle moves. So I wondered whether or not I could modify this and incorporate it on the end so that we could ultimately engage the cog and engage the other wheel so it could drive in certain circumstances. So if, for instance, he can't drive across a wet lawn, then he could just pull this lever and it would engage the other wheel and have both wheels driving. That's the idea. Watch this space. Okay, so it's another day. In fact, it's a few days have elapsed since I last did some video. I thought, well, in fact, I tried to video some of the work I did in the last day or two, but to be honest with you, they've been quite boring content because most of it was me head scratching, trying to come up with solutions to the problems that kept cropping up. So what I decided to do was to try to get to a point where I was confident about it working, and then basically show you guys it in being built, and basically me bolting it together, and then I'll sort of stop at various points and just explain things, well, my reckoning anyway. So here it is. You probably notice a couple of extra things here. I've got a couple of brackets welded in now, and I've got a tow hitch, which I'm already planning a trailer to go on the back of this thing, if it actually indeed works itself. So more on that possibly in another video, if this one ever gets to YouTube. So anyway, what I'll do is I'm going to start putting it together, and then I'm going to stop, because I've got I mentioned in prior to this about actually trying to make this axle a little bit special, and that it can drive both wheels, but not permanently. So in other words, you could drive on tarmac on one wheel driving, and then if you go a bit, if the sun goes off road with it and it finds the traction a bit difficult, you can actually engage the drive on the second wheel. So that actually, certainly on the bench, seems to be working. So I'll stop at the point where the axle's on. I'll put it on a time lapse and then show you how that works. Okay, here goes. Right, I got the axle on, obviously, and now's the best time, I think, to show you how the this sort of rudimentary diff that we've got going here, how it works. I'm going to spin the camera and place it onto the table, because I don't think I can do this with one hand. And I don't think you can see that either, which is a pain. I'm going to have to do this one-handed. Anyway, what we've got going on here is this. Well, basically this is the part that was in the centre of the disc. So I just moved it to the end and spun it around. Welded on a tube over the top of the shaft, and then drilled a hole through the shaft and allowed it to sort of basically slide up and down. So you can see it sort of slides in and out. So when it's up like that, it's obviously disengaged the drive to this wheel. So this is free, and then this is obviously still going. But so this will be when he's driving along the good surfaces, and then when he wants to do a bit of off-roading, he just basically flicks that on, and then off he goes. Obviously I need to do a bit more tweaking. It's not the prettiest looking thing, but it does work quite well. I need to take this down a bit and make it a bit smaller, and probably twist the bracket so that it fits a bit better, but it seems to be alright so far. Anyway, right, so on to the next bit, back on the time lapse, and see if we can get the motor on. You can see that then. Okay, so here's the motor mounted. I've got basically two brackets, a bracket with two bolts at the back, going right through the bit of L channel there. So I've basically welded a nut onto this one here, cut the bolt short. Bit fiddly to get in, if I'm honest, but when it's there, it's not going anywhere. Front bracket, one that's again pretty simple. Just welded a bit of angle there and a bolt through there. I was toying with making it adjustable, so I could adjust for the tightness of the chain, but I don't honestly think I'm going to get an awful lot of slip on this or stretch on this chain, because it's just overqualified for the job. Severely overqualified for this job, really, but it's all I had. So I'm going to basically cut the end off the pulley for the alternator and then welded on a spacer tube. I had to sacrifice the fact that I can't now get the nut off when I have the sprocket welded on the end, but I've not welded it on that hard. I just tacked it on really. I don't think it's going to need to be welded that hard or that well to take what we're going to put through the wheels, because obviously this isn't meant to go fast. How it's going to go, I honestly don't know. That's going to be coming up. At the moment I'm still waiting for the speed controller to turn up the right one. I ordered one I thought was a 36/48 volt, because I've got a 36 volt battery pack to put in it, but it turned out to be only a 48 volt and it won't work with the battery pack I've made. So but I will just go and get it and show you where I'm going to put the speed controller, because it fits quite neatly in there. Okay, so here's the speed controller. As you can see, it's a 48 volt, which isn't really any good for what I want. And there's the battery that I made. It's a 36 volt battery for my e-bike, and I was going to use it on this. And the idea was that it sits down in there. I'm going to make up an aluminium bracket or cover for it to protect it, and the speed controller is going to go in there, and then this one goes on the top quite neatly, or will do, and then it would all hide all the wiring and give it a certain amount of protection from the elements. Right, it's about 2 weeks since I last did some videoing on the go-kart, and as you can see I've done a few bits since then. In fact, it's fair to say that it's pretty much there. The speed controller turned up and it was the right one, which was good, and it worked. In fact, it worked better than I thought it would. So what I thought I'd do is just go through the bits that I've done since I last posted, and then if you have any questions, put them in the comments and I'll do my best to answer them. But yeah, let me just take it off. It's sort of semi got it ready to come apart. Let's see. As you can see, the battery pack is in. Obviously this isn't finished. What I want to do is just sort of mount like an aluminium protective cover around it, because it's going to get a beating, I have no doubt about that. Under here is the brains of the operation, and it's a bit of a bird's nest under here at the moment, but I'm going to tidy it up. So what we've got really 3 things under here that might be of interest to you. Here is the speed controller. This is a 36 volt 350 watt brush speed controller. Brushless speed controller, sorry. This is a step down buck controller, a buck converter even. I'll get my words right in a minute. This is to take the battery voltage down to 12 volt. It actually takes anything from about 36 volt to about 96 volt, which is on here. It actually takes 36 volt quite happily as well, and at 10 amps, and that is really for powering the rotor coil in the motor, because otherwise I'd have to have a separate battery just for that, just for these wires here, which would be a right faff. In fact, I did to start with before that arrived, and it was apparent I didn't want to have 2 batteries on this thing to charge up each time, so I thought we'd just try and do it all in one. So the buck converter was for that. And the other thing that I got, which as you can see, it's got a bit of dirt on it. It's actually been in use, and after I stop waffling, we'll go to the bit where a little lad who actually does his stuff and actually uses it in anger, and you can see it sort of working as it was intended. But one of the things that did in the back of my mind was that is to sort of control it. He's only 2, and so he hasn't got the concept of braking or stopping, and so this is where this little device comes in handy. It's a little wireless relay, and it goes alongside this, which is like a key fob, and simply it just turns the thing off. It actually turns the power to the rotor coil, and so it just all comes to a halt before he hits anything. And I can't tell you how glad I am that I put that on, as you'll probably see in the videos coming up, or the video coming up. Anyway, the only other thing to note in here was obviously I put a main switch for basically it all, so it can be isolated. And the one, actually there's 2 more bits actually thinking about it. This here is a potentiometer, and this sits between the throttle pedal, which I'll come to in a minute, and the speed controller. And all it does is it just varies the voltage it comes back to the speed controller. So it's like a fine tuner for the throttle. Because when I first put this together, without that, it went like hell, and I thought I'm never going to be able to keep up. So I thought, and he's only little, it's going to go too fast for him. So this is literally a speed control in its own right. And so if he's in a built-up area, just keep that turned right down, and he's quite safe when he's around other people and other people's cars and stuff. But if he gets into a nice big open car park or area, you can let it open it up a bit, he can just twist this around and off he goes, and it works really, really well. I'm very pleased with that. And then the only other bit was the throttle itself, because I couldn't get hold of one in any kind of reasonable time frame. Okay, I cut short there, sorry. Dog started barking next door, and I thought actually at the same moment I'll put the thing back together again, give you a demonstration on the stands how this works with the throttle pedal. I was the only part I couldn't get within a reasonable time frame, and Hall effect throttle pedals were quite scarce on eBay and anywhere else I looked, so I could have got one from China, but it would have taken a good 3 weeks. And I thought, well, actually, all they are is these. I don't know if you can see this, but basically, it's a tiny little sort of, I don't know what you call it, diode. I don't know. It's basically, it's affected by the presence of a magnet, and so once you've hooked up the power, what you get out of it in the green wire is a variable voltage between, I don't know, I can't remember what it was. It's up to about 5 volts, and then so basically if you put a magnet near it, it goes quiet and drops the voltage, and you take it away, you get full voltage, and then that's basically what makes the controller know the position of the throttle pedal. So I thought, well, that can't be that hard, I'll make one. And so I had a go and got this contraption, which is an old door hinge, and it's not the prettiest thing, but it works really well. And in there you can probably just see a couple of these magnets, and then here's the little sensor. And if I turn the thing on, I have to basically switch it on there, and then basically as I add the pedal, you can see it works. So yeah, quite pleased with that, and it saved me about 25 quid in the process. And what I was talking about, the potentiometer, as you can see, it's pretty, I've got my foot flat down now, and that's it going. And then over there is the potentiometer, which if I could dial up a bit. basically you get a difference in performance, quite stark difference if you just pull the knob. So that worked alright. For the future, what I think I'm going to do is put a cover over that chain to protect anyone's fingers going in it. I'm going to have moved from that little hand potentiometer down there to a wireless one. I've got one coming. That's coming from China. What else can I say about this? Oh, the one thing I hadn't anticipated, and it's quite a big one really. Converted alternators do make good motors, but there is one drawback that I had, and it may be just with this one, or they may all be like it, and again feel free to please enlighten me in the comments. But when I first converted this, I stuck an 18650 single cell battery onto the rotor windings to sort of energise it so I could test it. And after about 30 seconds this battery got really hot, and I thought, oh, that's quite interesting, it must be drawing quite a few amps. And so I sort of I basically stuck a 12 volt battery on it and measured the current, and it was drawing 4 amps at, even when it wasn't even turning. When it was turning it wasn't drawing any more, it was just static at about 4 amps. And so basically this is, I'm putting 12 volts into this, into the coil, rotor coil, and it's drawing 4 amps. So the whole time that this thing is on, it's drawing 4 amps, which makes it, in my mind, quite an inefficient motor to use for something like this. So it might be worth it might be worth taking that into account if anybody else is doing anything like this. On the whole, had I known that before, I still would have done it. I think I really thoroughly enjoyed doing it, and it's been pretty cheap. I mean, the most expensive bit is probably, what's it been, the I don't know, speed controller, probably 15 quid, something like that. It's, you know, they're all small, it's small price. The whole thing has been next to nothing. I mean, the battery pack is recycled laptop batteries. It's been pretty good. So yeah, that's pretty much it.